So the question is about work done by the gravitational force and the resistive force. It's given in the question, a drop of rainwater having a mass of 1 gram falling from a height of 1 kilometer. And when it is hitting the ground, the speed is given as 50 meter per second and the value of g is given as 10 meter per second square. So the total work done on the raindrop will be equal to its change in kinetic energy. So here we can say the total work done will be equal to kinetic energy. And this total work done is the sum of work done by the gravity and the work done by the resistive force. But there is no detail about the work done by the gravity and work done by the resistive force. And we don't have a value of kinetic energy also. So here we can calculate the value of Wg, which is nothing but the work done by the gravity by using a formula mgh. It's known that m is representing the mass, so the mass given here is 1 gram. When we are converting it into kilogram, it will be equal to 0.001 kilogram. Whereas G is given as 10 meter per second square, which is nothing but the acceleration due to gravity. Whereas H is nothing but from which height it was falling down. It's given as 1 kilometer, which means it's equal to 1000 meter. When we are applying all the values, Wg, or else we can say the work done by the gravity will be equal to 0.001 times 10 times 1000, which will be equal to 10 joule. So now we have a value of the work done by the gravitational force, which is 10 joule. Now we have to find the value of total work done, or else we can say the kinetic energy at the ground can be calculated using a formula half mv square. We have a mass value, whereas v is representing the velocity, which is given as 50 meter per second. So when we are applying the values, it will be equal to half times 0.001 times 50 square, which will be equal to 1.25 joule. So this is our total kinetic energy value, or as we can say the total work done. But here the question is about calculating the gravitational force work done and the resistive force. We have a value of work done by the gravitational force 10 joule. So now we need a value of work done by the resistive force. So now we can use the equation W2 is equal to Wg plus Wr. We have a value of W2 Wt because we said it's equal to kinetic energy. So we can write 1.25 will be equal to 10 plus Wr. So from this we can write the resistive work done is equal 1.25 minus 10, which will be equal to negative 8.75 joule. So the value of work done by the resistive force is equal to negative 8.75 joule and the work done by the gravitational force is 10 joule. So the correct answer for the question is option C here.